I have been able to work FM satellites fairly well with my limited setup for LEO satellite operations. Diwata 2, the Philippine microsatellite launched in 2018, known among amateur radio satellite operators as Philippines Oscar 101, PO-101, has been a bit difficult for me to work. Initially, it was because the schedule of activation was not known to us. But now we know the X page of Diwata 2, which regularly posts the activation schedule, as well as DF2ET satellite timer status page, which displays activation in green color and the time up to which it is active. Another bottleneck for me is that it is a UV satellite with uplink on UHF and downlink on VHF. So far, my antennas were not performing that well on UV satellites. Still, another reason is that very few operators in this region are trying to access PO-101. Recently, when I tried again, though I could not hear much, my test transmission was heard by VU2ADV. I am using my Moxon Yagi kept at a fixed elevation and azimuth prior to the pass for accessing LEO satellites. Azimuth is adjusted towards the direction of maximum elevation of the pass, which usually corresponds to the time of closest approach of the satellite. I use the Argentinian AMSAT webpage for manual Doppler tuning of my IC2730 radio during the pass. Prior to the pass, I will set my radio to the uplink and downlink frequency shown on that webpage, though it will be slightly different from the nominal frequency. Diwata 2 uplink is on 437.500 MHz with 141.3 Hz CTCSS tone and downlink on 145.900 MHz. The video clip is showing the CTCSS tone for uplink being set at 141.3 Hz. Here is a fast animation which shows the changes in azimuth, elevation, distance of the satellite and frequency of uplink and downlink. PO-101 is placed at an altitude higher than the International Space Station at 589 km in the illustration. Distance can be seen coming down from 2700 km at the time of acquisition of signal AOS to 600 km at the time of closest approach TCA. Distance of the satellite from us increases again as the satellite goes down to the horizon and reaches loss of signal LOS. AOS and LOS can be considered as rising and setting of the satellite in your region. As the radio horizon may be slightly different from the true visual horizon, operators with excellent directional antennas may be able to work satellites even at slight negative elevations, that is below the visual horizon. Maximum elevation reached in this pass was around 79 degrees. Down phase has not been captured in this animation prepared using sequential screenshots during the pass.